let's look at some problems that involve inverse trig functions. Our first one here says evaluate inverse sine of square root 3 over 2. Now this notation stands for the angle between negative 90 and positive 90 whose sine is square root 3 over 2. So if we say that to ourselves, we know that this angle must be 60 degrees in degree measure or pi over 3 in radian measure. So when I see this notation, I know that the angle I'm talking about has to be between negative 90 and positive 90, and its sine must be square root 3 over 2. Let's look at our next problem. Inverse tangent of 1. Well, the restriction on inverse tangent is also between negative 90 and positive 90, and I want the angle whose tangent is 1. Well, I know that that must be 45 degrees, or in radian measure, pi over 4. So the angle whose tangent is 1 that lies between negative 90 and positive 90 is 45 degrees, and then if you want it in radian measure, pi over 4. How about the inverse sine of negative 1/2? Well, inverse sine negative 1/2, the 1/2 tells me that I have a reference angle of 30 degrees. This inverse sine has to be between negative 90 and positive 90, so I'm going to say it must be negative 30 degrees, or negative pi over 6. So that's the angle between negative 90 and positive 90 whose sine is negative 1/2. So this sign right here tells me what quadrant it's in. I have to know what the restrictions are on the inverse trig function. Sine and tangent are restricted between negative 90 and positive 90. Inverse cosine is restricted between 0 and 180, or 0 and 2 pi. Now, if you're using a calculator to do these problems, your calculator already knows that. Let's try one more. How about the tangent of the inverse sine of 3/5? Well, I'm going to say let's let alpha equal inverse sine 3/5, because that's all this is an angle. So really what I'm looking for here is the tangent of alpha. Now, what do I know about alpha? I know that its sine is 3/5. So just to help me out a little bit here, I'm going to draw a little right triangle, and I'm going to put angle alpha right here, and I'm going to label the triangle so that alpha has a sine of 3/5. So if I label that side 3 and that side 5, I have a picture of a triangle with an angle whose sine is 3/5. Now I know from the Pythagorean theorem that this side then must be 4. So the next question is then, what is the tangent of alpha? Tangent of alpha must be equal to the opposite side divided by the adjacent side, so that's going to be 3/4. So with a little diagram like this, and going back to our second definition for the trig functions that involve right triangles right here, I can get a little picture. The main thing that you need to know about this notation is it stands for an angle, a specific angle. In fact, in this case, the angle between negative 90 and positive 90, whose sine is 3/5. Sometimes we can just work them out in our head. Other times maybe we let alpha equal that angle and then draw a little picture. It gets a little more complicated, then I can say tangent alpha is just 3/4.